Our next speaker is Shad El-Alam, Director, Product and Customer Success at SIA, Frilo, and DC. He will share with us the vision and benefits of the future workflow for structural engineers, detailers, and fabricators. Welcome, Shad.
Hello, Petra.
Shad, you've already worked in many countries and on major projects. What do you value most about being part of the ALLPLAN product team?
Well, it's a good question. It's very important to think that regardless of the country where we work on, our workflows might change a little bit from one country to another. At the end, what we are searching for is we have a goal, and that goal is actually to build our structure the most efficiently and the fastest possible. We want to build structures that are safe and stable. Part of my experience is that thanks to seeing multiple workflows, I'm able to really think of how we can address these challenges that faces us everywhere, regardless where we work, regardless our discipline. We all face challenges, and we are here to address these challenges and really to provide the best workflow designed to build.
And now, have fun with your presentation.
Thank you, Petra. Hello, my name is Shad El-Alam. I am the Director of Product and Customer Success at SIA, Frilo, and DC. I'm going to present to you today the future workflow for structural engineer. What is really structural analysis, and how does it fit in the design to build workflow? If you're joining this event, it means that, just like me, you are a real enthusiast of the construction industry, and you're fascinated by the structures around us. Whether you're an architect or an engineer, we all play a significant role in the complete design to build workflow. But have you ever paused and stopped for a bit and thought, where do I fit in the big picture? Today, I'm going to talk primarily about the role of structural engineering, and mainly the structural analysis part, a crucial discipline that is intertwined with all the others. We will see here where it fits and how it fits in the complete workflow. How is it integrated now in our offering, and how will the future shape it? Structural engineering is not a new discipline. It is the backbone of our construction, from small buildings to skyscrapers, from small bridges to big bridges and other civil structures. But as a discipline, it is not new, far from it. It is a discipline that dates to the early ages, starting with the very need to find shelter, for example, and it evolved with time. Since history, humans have always dreamt of building big, imposing structures, like the pyramid, for example, and engineering played a big role in every single one of these projects. As technology advanced and new materials were discovered, our construction methods and our techniques transformed, paving the way for new architectural achievements. Take, for example, the Eiffel Tower. It's a very nice example. This marvelous structure wouldn't have been possible if we did not invent wrought iron, for example, during the Second Industrial Revolution. Just think and imagine the countless hours Gustave Eiffel must have spent with his team writing down formulas, making sure that the structure is safe and is still standing till today. And just think of how many iterations and hypotheses they had to go through before the construction even started. Today, our capabilities are further expanded by groundbreaking technologies. Our boundaries are pushed to the limit, allowing us to dream bigger and build higher. New structural analysis solutions have advanced and are leveraging the powerful computers that we are using daily. These technologies are making it possible to make the architect's dream a reality. And just now, skyscrapers surpassing 1 kilometer are already in development. Building the impossible is now made possible. Now, if we take a look at the big picture and try to imagine the journey that a building goes through before being constructed and used, we can identify many disciplines that are involved in the whole workflow. But is one role really more important than another? Definitely not. Every discipline plays a crucial and comprehensive role, and every discipline is essential for the building being constructed. But it actually requires a constant collaboration between the different stakeholders, of course. And constantly the stakeholders need to be informed and connected. So you might ask yourself, where does structural engineers fit in all this? And particularly, where does the analysis part fit in all this? As you have guessed, it is not one single action that happens within time, but it's an iterative process. An engineer might have an impact at a certain time, and then he might jump in again to do another interaction. Let's take a perfect example, for example. The engineer will receive the drawing from the architect. He will do the analysis of the building, the complete analysis of a 3D structure in solutions like SIA Engineer, where he will apply all his load and see the behavior of his building. And he might also need to go into more depth and more detail, and that's where component-based solutions are there. So he will go select a beam, a column, or a plate, for example, to do thorough analysis and thorough design. And after this, of course, you have all the excavation. So you have the foundation analysis, you have the soil mechanics, and that's a crucial part of the analysis. The engineer, as I said before, will have to go back and do certain modifications as he receives them to make sure that the design and integrity of the structure is still okay. And this is not where the role ends. Of course, information about the design, like reinforcement or type of elements that are used and materials, will need to be communicated to the other stakeholders. Regardless where you fit in the complete workflow of design to build, remember to look at it as a complete puzzle, each discipline holding an important piece of it. Okay, so we have talked about the role of structural analysis, and I hope that I was able to highlight how crucial it is, but most importantly, how it is connected to the other discipline and not at all isolated. With now SIA, FRILO, and DC, 3 structural analysis solutions merging with ALLPLAN, it is important to highlight what this will bring to the industry, what this will bring to you. What does the workflow currently look like? And where are the challenges facing us? As I mentioned previously, different disciplines are involved in the whole design to build workflow, from engineers to architects to detailers and others. But are they able to all work on one structure efficiently? And how is the information shared and communicated? Well, we know that this information is important to be communicated. With every change, we need to provide hundreds of documents and hundreds of files. Just imagine that with each revision and each minimum change, you need to inform all the stakeholders. Luckily, of course, many of this process is now digitalized. Okay, but did we really solve the problem? Or did we simply take the stack of drawings that we had on the desk and just put it on our desktop or on our inbox? With so many information being shared, we are losing time in repetitive tasks. Each engineer and architect are modeling their own structure alone. And in many cases, the model is being built and built over and over again, which makes it difficult to track the changes. We are losing a lot of time to check and see if we are working on the latest revision. And this is crucial to make sure that we are not wasting time and effort. All of this is actually due to one thing. It's working completely in silos. Each discipline is working alone, separately, each looking at their own workflow, failing to look at the big picture. Imagine now a world where these barriers start to fall, where technology not just connects us, but really unites our workflows into a seamless, integrated process. This is not a distant dream, but now it is a reality. With the merger of SIA, FRILO, and DC to ALLPLAN, we are not just bringing solutions together, far more than that. We are also bringing people together. We're stepping into a time where the entire design-to-build process becomes more cohesive, efficient, and aligned, breaking down the traditional idea that each should work separately and paving the way for a more synchronized and harmonious workflow. Now, what does this mean? This means we can now envision more collaborative and efficient projects. Architects, engineers, and detailers can work within a unified system where changes are instantly reflected, reducing errors and speeding up the project's lifecycle. This synergy not only enhances project delivery, but also fosters innovation, allowing us to push the boundaries of what's possible in construction. SIA, Frilo, and DC have been part of the Nemetschek Group for years. And collaboration with ALLPLAN and other sister brands have always been ongoing. But by merging together, we are looking to go beyond just collaborating and really looking to unite our workflows, bringing you a complete solution designed to build. Let us quickly look at what are these solutions, in case you don't know them yet. First up, SIA Engineer. It's a versatile 3D solution that enables you to model any type of structures, from bridges to skyscrapers, across various materials, supporting many types of analysis and nonlinearities. It streamlines your workflow with its straightforward modeling capabilities and integrated engineering reports, saving you valuable time. Next, we have Frilo, which is a large suite of solutions catering to all your engineering needs. Whether you're working with steel, concrete, timber, masonry, or any other material, or whether you have a beam, a column, a slab, or a connection, Frilo's component-based approach ensure you'll find the precise tool that you need. And the third solution, DC Softwares, offering an extensive selection of options for geotechnical and soil mechanics engineering, addressing a wide range of specialized needs in this crucial field. Now, let us pivot a little bit our discussion towards the horizon, in an industry often perceived as traditional, not changing as fast as other industries. But we believe that currently it is starting to rapidly catch up with technological advancement. What are the challenges ahead and how are we going to address them? We don't just want to build something for today. Our aim is to build something for the future. And in our journey towards building for the future, the first cornerstone we have is accuracy. The complexity of modern projects and having a large number of variables and inputs dictates the need of more and more precise analysis to be performed. With the demand of economical design rising as well, fast and quick assumptions are to be avoided. Our second cornerstone in order to build for the future is without a doubt safety. We have seen in the last years the increasing numbers of natural disasters, from floods and hurricanes to earthquakes due to global warming. These events have shed light on the need for more and more resilient buildings and infrastructures. These events are not just warnings, but calls to action for every architect and engineer out there. Building for the future means building structures that are safe at all times and can withstand these severe conditions. Our design must be safer than ever, ensuring that when the storm passes or if an earthquake hits, our structures remain safe, a testament to our dedication to protecting lives. But how exactly do we achieve these essential cornerstones, accuracy and safety? They really go hand in hand. And the answer lies in leveraging the technological advancement in analysis, like our solutions, enabling us to model and predict structural behavior of our building. For example, to be able to simulate the impact of a severe wind load on a structure will allow us to accurately see the impact of a hurricane that hits the structure, and it will help us ensure that our buildings are designed to resist such a force. Time is another critical factor. But why is that? Because it has impact on our construction materials, like concrete. And by taking account time, we are able to consider cracks, creep, and shrinkage, which will lead to a reduction of performance in concrete. Of course, many other types of analysis are also important to be performed, like seismic analysis, in order to see the response of a building during an earthquake, and to be able to design our structures that are safe. Taking into account the different stages in construction is also very important. And of course, many other types of analysis and nonlinearities are also needed to be taken into account. Accuracy and safety are also dictated by codes and standards in different countries. And in the coming years, we are going to see a new generation of Eurocode that will be published and that will replace the existing one. In these standards, the latest research and findings are included, making sure that our designs are safer than ever. How can we build for the future if we don't talk about sustainability? Sustainability will play a major role in the industry in the coming years. And it is not a surprise if we look at the stats. The construction industry is responsible for approximately 39% of the global CO2 emission. This includes emissions from the production of building materials, construction process, and the operational emissions of building. Construction and demolition activities contribute to a significant portion of waste worldwide. In Europe, this is estimated to be 35% of the total waste that are generated, and 50% of all extracted materials end up in the construction industry as well. These figures underscore the urgent need for sustainable practices. It's a call to action for all of us in the industry to innovate and implement solutions that reduce our environmental footprint. So, what does it mean for us, and how does structural analysis fit in all that? The area of construction materials is witnessing a rapid evolution, opening the door to innovative and cleaner alternatives to our standard construction material. We already saw new resin-based materials that could potentially replace traditional rebars in concrete, and many other promising initiatives. Furthermore, the adoption of green concrete and timber is also on the rise. We have seen that in recent years, and we have noticed an increase in the use of timber in the construction industry. This is not just for its aesthetic and structural benefits, but also for it contributing significantly to reducing the carbon footprint over a building's life cycle. Besides the new materials, we're going to see more and more recycling and reusing of structural elements. While the recycling of non-structural element materials like ceiling and doors is commonplace now, we will start incorporating recycled structural elements more and more. Mainly, for example, for steel, since it conserves its properties over time, but also for other materials. Just imagine a big warehouse filled with different steel elements, different sections and different lenses. Engineers can connect to this warehouse to see what can they use from it in order to integrate it into their analysis. This practice will not be about resource efficiency, but it's a transformative approach that reduces waste and emission. Okay, computational design. So this type of design is not really new, but with more and more powerful machine and complex structures that are being built, we will be able to do great things with this technology. But first of all, what is it? To put it simple, it's a graphical parameterization, a graphical sketch with different inputs and parameters like you see behind me here on the screen. And these scripts will translate into having our complete model drawn, like we see in the pictures behind me. And of course, what's particular is that it's much easier than asking an engineer to code. And the learning curve is much faster since it's really graphical parameterization. Our structure, as I said before, are more and more complex with a lot of variables, a lot of different inputs from the design to checking carbon emission to prices. Many factors come to play when looking at the best design and optimal design. And here is where computational design is going to come in to enable us in checking multiple solutions and iterations in order to find the best design that answers all of these criteria. With resources in time and engineers less and less, computational design will allow us to save enormous time and a lot of tedious work. It's impossible to overlook the transformative power of artificial intelligence and machine learning. Over the past years, we've seen these technologies redefine possibilities across various industries. To imagine the construction sector remaining untouched is frankly a denial. AI and machine learning are not just buzzwords. They are essential tools in the evolution of structural engineering and analysis. By harnessing these technologies, we can predict structural behaviors with unprecedented accuracy. We can optimize materials and design for both efficiency and sustainability and foresee potential future failures before they even happen. Just imagine artificial intelligence and computational design being used together. Now, let me quickly address a taboo. This will not replace engineers or architects, but it will allow them to really make better and faster informed decisions. With the fourth industrial revolution and its advancement from mechanization to digital interconnectivity, Construction 4.0 is identified as the next major revolution in our industry. This new era will be characterized by the fusion of digital and physical worlds, where connectivity will enhance our traditional construction methodologies, revolutionizing also our fabrication processes thanks to automated machinery and robotics. Let me illustrate it with an example. Imagine a structural engineer that will connect to a digital twin of the building or the structure that he's working on. He can immediately track all the changes happening on site thanks to monitoring equipment that are already there on site. And he can even see the impact of wind on the construction sites. Thanks to all these sensors and all these informations, now he can reassess the integrity of the building. And once the design is finalized, the fabricators are instantly informed and can track the changes as well. Now imagine that based on that information, he can now calculate the integrity of the structure, and with the design finalized, the fabricators are instantly informed with one click. The role of structural engineers in all this is more and more critical. With the power of digital twins, Internet of Things, and data at our fingertips, we stand on the edge of revolutionizing how buildings are designed, constructed, and maintained. But beyond technology, it's the collaborative spirit, the shared vision of excellence and sustainability, and the relentless pursuit of innovation that will drive us forward. Thank you.
Thank you, Shad. I'm impressed how ALLPLAN brings structural analysis into the design to build workflow and reshapes the way we think about and create our built environment. So joining forces with ALLPLAN must be a very exciting process for you. What are you looking forward to the most?
Well, it is really an exciting journey that we are now on. And the thing that I am the most looking forward to working on is really taking a step back and no longer looking at it as structural engineering workflow, but really looking at the complete design to build workflow. Structural analysis was a main, let's say, a big piece of the puzzle that was missing. And now we have really the full picture, design to build. Mm-hmm. And I'm really looking forward to shaping this workflow, providing our customers the best solution.
Yeah, very exciting. Thank you for being with us today.
Thank you,
Thank
Petra.
you.